Welcome to lecture 58, Causal Modeling 2, Application of Path Model, under module 12, Behavioral Safety Analytics and Injury Epidemiology. Please recall my last lecture where I discussed causal modeling with reference to path model. I described that why path model is used when several variables are related structurally, within certain structure, and the structure gives you several paths. We discussed the path model in connection with regression. We have shown you that how the multiple linear regression, two multivariate multiple linear regression, and finally the path model. And in the path model we have also discussed the different kinds of variables involved, different kinds of relationships involved, and also I have shown you that what are the steps for path modeling, and then what are the different kinds of effects are there, like direct effect, indirect effects, as well as the total effect. And then finally I discussed that what are the different goodness of fit measures that are used to understand whether the given data is fit to the conceptualized path model or not. So this lecture is basically application of the concept what we have discussed in the previous lecture. So we will describe a case study and what are the different relations there, hypothetical relations, what kind of data we have captured. Then we have done the validity and reliability of the data. We did preliminary analysis with reference to some plot as well as t-test, and then we have gone for detailed path modeling. Then we have seen that whether the model fit or not, and finally from the model parameters, estimated model parameters, we have generated key insights useful for the management of the organization where we have done the case study. This lecture is completely based on our previous work published in Safety Science, and my co-author is Dr. P.S. Pal. This case study, I first explain what is this study. The study was conducted in two neighboring underground mines. The mines were selected because work injuries of these mines are high. One mine was declared as accident-prone mine. The mines comprised a total of 1,000 underground workers. Those are directly involved in production. The sample, what we have done basically, we have developed questionnaire, and the questionnaire was administered to 300 underground mine workers. So, and obviously it is done randomly, usually at the beginning of the shift and the end of the shift, and we found that 80% was the response rate, and we have adopted the method called frequency matching, because we created two groups. One is accident group, means the workers in their tenure or entire tenure in that particular mine, they have basically experienced some kind of injuries or accidents, some kind of incident experience is there, and then another group who has not experienced any such incident. So we have taken 50% of that respondents from the accident group and other 50% from the non-accident group. Accident group means the group of employees who have prior experience, either by observation point of view or by being affected or by being affected from the accident or any kind of incident point of view. Then on an average, the participants were 37.34 years old with 9.01 years standard deviation, and they have their job experience more or around 14.58 years average experience, and standard deviation 9.25. Of the injured, 65 were from mine 1 and 85 from mine 2. So, this is basically the description of the mines from where the study was conducted. What was your objectives of study? The study was conducted to understand the role of behavioral factors on the occurrence of mine accidents and injuries. Here, the difference between behavioral characteristics of accident involved, that we are saying their case, and non-involved, these are controlled, we were examining. Means we created two groups of workers, one group accident involved group, another one is non-accident involved, meaning no accident exposure is not there. So, these two groups we considered, and based on frequency matching methodology, of the 300 participants, 150 from the accident group, another 150 from the non-accident group. This is somewhere case control study. It also explained the nature of relationship between the behavioral factors and work injuries. So we wanted to know that what are the nature of as quantity of quantum of relationship, whether they are positively related, negatively related, what is the amount of relationship or magnitude of relationship, that is the other objective. Okay. Now, with this, the variables you have already seen in my last lecture, these variables we have considered, and we have developed a hypothetical model like this, where you see that the three endogenous variables, 4 exogenous variable, and then you find out that that work injury is the safety outcome variable, and that also depend on 2 other endogenous or dependent variable like safety performance risk taking, that I have discussed in the previous class also. In addition, in previous class I have shown you that this kind of hypothesis and the nature of relationship as well as the quantity of relationship we tried to model using this concept. Okay. Now, what are the instruments? How we have collected data? First, we have developed questionnaire. Now, you see that what are the questionnaire we have developed. So, first of all, miners age, miners means mine employees, age, experience we got from their employee record, negative effectivity, risk taking attitude, job dissatisfaction and safety performance we through questionnaire survey, and work injury from the also from the records. Okay, so you see that miners age and experience from personal logbook, construct negative effectivity, risk taking and job dissatisfaction through questionnaire survey, and the safety performance of each respondent was obtained from the respondent's immediate supervisor rating. So, safety performance, supervisor rating, I think we consider 3 immediate supervisors rating, yes, who are basically looking at that. The work injury was measured through dichotomous variable. The injury group participant score got 1 for work injury variable and 0 other group for other group obtained from each of the respondent personal records. Then for job dissatisfaction, we developed 13 question, risk taking 11 question, negative effectivity 15 question, and what is job dissatisfaction, what is risk taking, what is negative activity, these are the description. Job dissatisfaction means overall negative feeling of the worker towards the job. Negative effectivity means chronic experience of negative emotional state and lack of emotional stability. Risk taking means voluntary participation in a behavior that seems to contain a degree of risk. Then there are one sample question we have given here, and the mean point of view, the different means and the standard deviations are also given here. So then validity point of view, basically factor analysis was done, because for every, suppose the for example job dissatisfaction is the construct with 13 questions. So we take 13 questions, each one of them as the manifest variable, and then job dissatisfaction is the factor, and we have gone for one factor analysis, and then from the factor loading we have understood that whether there is significantly related or not. If any loading less than 0.3, that we consider question is discarded. The correlation of the remaining questions for each construct were computed, question with low correlation were deleted. So that means how we have done it. Factor loading of each question on their respective construct were checked based using factor analysis. If any loading was less than 0.3, it was discarded. Then the correlation of the remaining questions of each construct were computed. Questions with low correlation further deleted. The remaining questions were considered indicators of the construct. For example, negative effectivity, 2 questions were found to be insignificant through factor analysis, while 2 more were discarded through correlation calculation. Risk taking, job dissatisfaction were measured by 9 and 12 questions respectively. Then after that we have done the reliability study. In the reliability study, internal consistency reliability of each construct was measured, and a Cronbach alpha value of 0.7 or above is considered acceptable. Then Cronbach alpha for negative effectivity is 0.83, Cronbach alpha for risk taking and job distribution 0.82 and 0.83. So these are much more than 0.7. So internal consistency reliability is satisfied. So that means from the factor loading point of view it is satisfying, reliability point of view it is satisfying. We thought that this is good. Now with the data, first what we have done, we tried to see that whether there is any kind of differences with the individual variables. For example, we created high-low plot. What is the high-low plot? Now we have, in the y-axis we kept number of respondents. That means there are 2 groups. One group, that is the dotted one, is the non-accident group, and the firm one is the accident group. So you can see that in each of the plots actually there are 2 lines, one dotted lines and one firm lines, and the x-axis the respondent score on risk taking, similarly on job dissatisfaction, on negative effectivity, on safety performance. Now you see that what is actually happening, respondent score on risk taking, if we see the number of respondent, when the score is less, you see the non-accident group people are more, because and when the score is high, that accident group people are more. So it simply indicates that means the risk taking behavior is shown more in the accident group of workers. Thus that also we see in the job dissatisfaction point of view similar pattern, then negative effectivity point of view similar pattern, safety performance point of view exactly the opposite pattern, and it is obvious also because safety performance is a positive variable. So here we found that accident group performance is lower than the non-accident group performance. So this gives you an idea that how accident group and non-accident group, they are basically performing under different safety factors like risk taking, job dissatisfaction, your negative activity and safety performance. In a graphical representation, although you are getting certain difference, so that you are seeing the change in pattern from low risk taking to high risk taking, low job dissatisfaction to high job dissatisfaction and so on, but this is visual only. So if you can quantify statistically using t-test, that we have done here. So what we have done here, we have seen that from for the different variables point of view, starting from your job dissatisfaction, negative effectivity, risk taking, job dissatisfaction, negative activity, risk taking, safety performance, in addition age and experience. Then what we have done here, we found out the mean or average response for in the two groups, the non-accident group and accident group, and what is the difference, and then we try to find out whether the difference is significant or not. Interesting part is that in all the cases the p value is almost 0. That means the two groups differ in terms of their variables like age, experience, job dissatisfaction, all those things. Although age and experience, that difference point of view, that is okay, gives some idea, but the other factors like job dissatisfaction, negativity, risk taking, safety performance, the difference is actually very important one. What we can find out here, that from the age point of view, that means accident group are older, 39 and 35. So if we try to do individual analysis from age point of view, we can conclude that higher age group people are having more experience, more injuries or some kind of things. But at the same time, then we have to see that when we are asking the question, what way we have asked the question, as you consider if for the particular time period, we consider the entire lifespan, not lifespan, entire experience period, then obviously that difference you have to explain accordingly. From the experience point of view, we are also observing the same. Job dissatisfaction point of view, yes, higher age group or accident group are more dissatisfied. Negative activity similar, risk taking similar, and as well as safety performance the other way around. So that means what we have seen in the low high plot, so this the mean difference also accordingly reflecting the same, but the difference t values are important. These t values basically quantify the what is the magnitude of difference. Okay. From this bivariate analysis, I can say bivariate, better I can say t-test means univariate analysis. From this univariate analysis, you are getting some idea, yes, the difference is there between the two groups of people. But it is not talking about some kind of direct or causal effects, cause and effects. So that kind of relationship is not coming from here. Here the difference is there, that is coming. So as a result, what happened in our hypothesis model, this data is fed, and then first what we have checked whether the data captured with reference to this causal model or path model, whether they are fit or not, then the fit statistics is given here. So chi-square is low by point this one 0.03, acceptable yes, goodness of fit 0.99 yes, adjusted goodness of fit also very high yes, root mean square low yes, and non-fit index 0.9 yes. So that means the fit measures, some of the fit measures we consider, not all. So fit measures are acceptable. So we can, that's why we can say yes, it is basically fantastic that the model, causal model is fit here. In addition, we also tried to find out that squared multiple correlation, then that means we have three endogenous variable or dependent variable in the path model. How much variability of each of the dependent variable explained by the model. From the data we found out that the squared multiple correlation for safety performance is 0.07, be very low value. That means the explanatory variable for safety performance we consider age, experience and negative activity. These three are not able to explain more than 7%. So, very low value, but if we consider work injury, where in addition to the exogenous variable, independent variables, the dependent side safety performance risk taking also considered, and the 70% of the work injury variability is explained. So, it is a very high value. Similarly, risk taking, where risk taking attitude we are measuring using the 4 exogenous variable as well as safety performance variable, and it is 42% variability is explained. And in such causal model, you will find out that explaining even 30% of the variability of the dependent variable is also a critical one. So, considering this 30% is many times non-achievable, so we are happy with the square multiple correlation, means the percentage of variability of the dependent variables of the path model as explained by the model. So, that is also interesting, and it is also supporting that yes, we can use this model. Particularly, we are happy because of the work injury is explained quite large extent, risk taking also is explained quite large extent, and risk taking behavior is one of the key important part in the behavioral safety analysis. So, we thought that this kind of study definitely at least quantify that actually risk taking things are happening, and with the relation between other factors, some kind of positive interventions that can be developed. So, what I mean to say now so far, that yes, the path model with the collect questionnaire design based data is able to describe the behavioral part of the workers in terms of accident and injury occurrences possible. That is basically the first part what I want to tell. That means we are accepting the model as their fit measures are good. Now, what we want to do? We want to see, fine, we know the model is fit, but now we want to see that how each of the variables affecting the dependent or endogenous variables. What is the amount of relationship? What is the sign of relationship? If you see here, suppose we want to understand the safety performance vis-a-vis its relationship with age, experience and negative activity. So, you see that age and experience, the coefficient values are low and they are not statistically significant also. So, as a result, we can conclude that age and experience not contributing to safety performance, whereas if you see the bivariate case, univariate case where non-accident and accident group in terms of age and experience, the difference if you see, you will find out that yes, there is gross difference, but actually these two are not contributing based on this model and with the data collected. Negative effectivity is negatively contributing in the safety performance and its effect is minus 0.24. It is a quite large value. And now issue is that actually the people at the workers at this place, they are having lack of emotional stability. There may be reason. So, that means what kind of intervention is required in order to improve safety performance? That means some kind of psychological counseling or some kind of soft psychological or social intervention is required. Maybe motivation is one of the factors, as you see in the ABC model, motivation factor is there. So, you have to work on that. For the accident group of people, you have to understand that what kind of motivational scheme should be there, so that the safety performance will improve. Now, if you consider risk taking as per se, again I found that age and experience, they are insignificant, but negative activity and job satisfaction, they are highly significant, positively related. So, highly and positive relationship is quite obvious, when it is expected also, and the value is, this is standardized coefficient, means it will be maximum 1, minimum positively, 0 to 1 or 0 to -1. So, that kind of things. The magnitude, absolute term maximum will be 1, minimum will be 0. So, 0.45, 0.30 is a large value in that sense. So, it indicates that risk taking attitude, although we say the person taking risk taking, this may be because of the other variables. So, again the negativity, job dissatisfaction, they are more on that social and organizational issues. Okay, so motivation, incentives, some kind of enjoying the work. Okay, then hazard, physical hazards and other things are there. So, please understand, it's an underground mine. So, people, we are talking about mine workers who are basically doing drilling, blasting and that loading kind of job. This is highly hazardous situation. At the same time, job is very laborious also, and it is quite obvious that this negativity or these things will be there. So, that means focus should be given from the social and intervention point of view to feel them proud to work with the motivation scheme, with incentive schemes and something like this. And obviously, if you see the work injury point of view, the interesting part is that age positively and significantly related, whereas experience is not related, and but all others like negative affectivity positively significantly related, job dissatisfaction positive, and risk taking also positive. So most of the explanatory or variables or predictor variables here, they are affecting significantly work injury. So you have to say that the safety performance minus 0.71, risk taking 0.13, age is one of the important part positively affecting, means older age group, they are having more number of injuries, in the sense it is not good enough. So, what I mean to say here that yes, this kind of modeling gives us enough inputs that where to focus. If you want to improve work injury, you see all the red colored variables you have to focus. You have to identify appropriate interventions related to these variables, and as these are primarily soft variable in the sense with reference to the social and psychological variables, so that means social psychological that interventions are important. They are more or less, because we talked about individual coefficients with reference to primarily behavioral factors. We have not included the technical factors here or other organizational factors here. So, if we bring those factors together, so obviously maybe the result will change, but within the individual behavioral factors point of view, this, if we consider that this is significant, this study is representative one, and then obviously these are the findings, and these findings you have to use carefully in order to design for interventions, mostly maybe administrative control, organizational, incentive or motivational issues to be taken into issues. Okay, so here I talked about, okay, there is the effect, but in addition, what we have done, we tried to give some kind of ranking, that which variable age affecting the maximum, whose rank is 1. If I cannot go for safety related interventions with reference to all the variables, can we go find out that where we should concentrate first, and then where is the second and where is the third, something like this. So, that can be done through direct and indirect effect or total effects point of view. Path models gives you total effect, and from the total effect you can give a rank. Here you see we are talking about with reference to work injury only. So, with reference to work injury, this is the issue. When you do the same thing with reference to safety performance, you get another rank. With reference to risk taking, another rank. So, fantastic. So, that you can do. But for the with reference to work injury, you see that each of the cases what are the direct effect, that means directly one to one, that one directional arrowhead, what is the coefficient value, plus indirect mean how many indirect paths are there. So for work injury vis-a-vis age, this is one indirect path, this will be another indirect path. Okay, so these two indirect path totality, that is the total contribution. Direct 0.28 contribution, then total this plus this 0.36. So in this manner, experience this plus this minus this, negative activity plus 0.33, job distribution 0.16, risk taking this. So two things are important here. The safety performance is very high, 0.72, risk take age 0.36. So these two coming first and second. One is safety performance. Now again safety performance, probably whatever the factors variables you have considered, they are not good enough to define or to explain the variability in safety performance, because the error variability here is 0.93, that explained variability is only 0.07. So that means this model, although is telling that safety performance is an important variable, but why safety performance is poor, so for in the accident group this model is not able to tell you. Mean you have to develop another model with reference to safety performance and then find out what are the other variables affecting safety performance. So this is interesting way of understanding that where to put your resources. So with this I close that this application part. I have shown you that how path model can be applied in real life problem solving, particularly from the safety improvement point of view. Here this model will actually tell you that what are the factors or variables important, and so and which one to be considered first, second, some kind of prioritization, and based on this finding, now the next level work is required, that okay, if I want to improve upon risk taking, so what are the variables? We found out dissatisfaction, job dissatisfaction is one of the important part. Risk taking, negative activity, another important factors. So you have to concentrate on those variables, improve this, and obviously you will get the good result. So this lecture and the previous lectures, the previous one lecture, these two lecture basically completes the path model as a causal model from the safety performance evaluation point of view. Application side we have shown only on the behavioral factors what we have considered. We have not considered all behavioral factors, we have considered a few behavioral factors what actually we found important during the time of the study. But there are many other ways the model can be developed. You can use in our first lecture of this week, there are certain 3-4 models we have already given. You can use one of them as a reference, collect data, and then analyze the data, and after that find out the appropriate design solutions, maybe engineering way or maybe administrative design solution, and that definitely will help you in improving the safety of people at work. With this, I am thankful to you for your patience and kind listening to my lecture. Have a nice day. We will meet in the next class.